Okay, this is Module 3, Lesson 10. I'm going to do from the homework first page here from the Common Core. Again, the Common Core worksheets are available online. Anybody has access to them. You just have to do a quick search on Engage, NY, Engage New York, .org. Now, or you could just Google Engage New York, Google Common Core New York. Any of those methods will eventually get you to their website, and you can go through and find the homework. It is all available to the public. But anyways, the main thing that they're asking for in this particular lesson, just like the last one, they want you to basically find a common denominator, and can you do it with mixed numbers too? Now, mixed numbers is really not an additional difficulty. It does make the problem look much more confusing, but one thing I like to do is say, let's get rid of these. In pencil, if you do it lightly, you could still read it. I just did that in a very dark color, so you can't even see them. But one of the reasons that I like to do that is what makes this problem hard is not the whole number. The whole number is irrelevant for most of the problem. They're really asking you, can you add or subtract fractions? And now I can't read a thing, so I'm going to undo. And can you find the least common denominator, convert these to an equivalent fraction with that least common denominator that you just found, and then perform the operation, in this case addition. Although it doesn't matter, addition or subtraction, those two operations you can do with a similar or the same denominator. If it's multiplication or division, those are different, and those would be addressed in other lessons. So the first thing, of course, you always do is find the least common denominator with fractions, because you can't really do anything until that's done. So the easiest method that I think is also the quickest and most efficient way to do it is to just list down the multiples, because you want the least common multiple. So multiples of 3, 3, 6, 9, 12. Let's go 15, 18. Now that should be high enough, but we don't know yet. So let's see. 7, 14. Nope. 21. Oh, we're already high. So 18 plus another 3 is 21. So 21 is going to be our least common denominator. Sometimes you have to go one side for a while, especially with a low number like 3. You might have to go down for a while, but if that's the case, usually the other side you don't have to go far at all. I remember one time I went into the hundreds looking for a common denominator. That was in middle school, so hopefully you won't see that in the 5th grade module, but if you're that high, you probably just missed it. And 21 is the first number that's common between both of these numbers, first common multiple, and it's the least, the smallest, so 21 it is. Alright, I'm going to undo this so we have room. I just wanted to show the process. But space is like gold on these things. So 21. 21 is our new denominator for both fractions. We're not changing the fraction really. We're just making it appear different. But its actual value does not change. That's the important thing. That's why they're called equivalent fractions. Now, 3 to get to 21 is times 7. 3 times 7 is 21. And whatever I do to one fraction on the bottom or top, I have to do the other. So the top has no choice but to follow and be dragged along times 7. Otherwise, it would not be equivalent. So 7 over 21 is equivalent to 1/3. And if you look at it, 7 is a third of 21. So you could always reduce or simplify the answer down to 1/3, to its lowest terms, which we have not, this module has not gotten into reducing fractions, but it will be an important skill coming up in future lessons. And once you do that fraction, this one's done. You can actually just cross it out. It's done. Now, 4/7 needs to be converted into an equivalent fraction as well. So let's go ahead and do that. I'm going to do green. 7 to 21, that's times 3. And the top has to be times 3 too. And that's pretty easy. You can do most of these in your head. They're not really sophisticated problems. It's usually small numbers. 4 times 3. And there are other ways to show it. This is the way that I have always taught students, but I'll do real quick an equivalent way to convert to equivalent fraction, a slightly different looking way. You can also stack them 1/3 plus 4/7. There are some teachers that prefer that method, and there are, I think that's almost equally as easy or simple to do. So just keep in mind that there are many other ways to do it. Although you're really always doing the same process, just it looks a little different. That's all it is. So 4 times 3 is 12. And now I've got 21, 21. Now we're talking because I can add the top, the numerator, and of course the denominator is still going to be 21 regardless of what we do up here. But 7 and 12 is 19. So that's pretty much our answer once we go back to the whole number part. I like to cover them up because they can be distracting, and they just make everything look much more complicated than it needs to be. So once we get the fractions out of the way, we're in a much better situation. So the answer really is this plus whatever the whole number. And 2 plus 4 is super easy. Yep, 6. 6 and 19 over 21. The whole numbers are never going to be difficult in these. They just want to make it look confusing because they're measuring, can you, in a confusing mess of numbers, take out what's important, do what you need to do to those numbers, and then kind of add things back together at the end with these whole numbers. And if you do it step by step and just do it in small chunks, it's much, much more simple. But as a whole, it looks complicating. 19 over 21. And even if I were to simplify this fraction, 19 is prime, so you can't simplify 19. So this would be actually as low as you can ever go, even if we did simplify 6 and 19 over 21. That'll do it. Have a great evening or morning or afternoon, whichever one applies. Bye-bye.